Okay, this is again a counting principles question from the review pack for the trimester one cumulative exam. And what this says is we've got 8 runners, and those 8 runners are competing in a race, and we can't get a tie. Okay. Andrea and Jack are 2 of the 8 competitors in the race. Find the total number of possible ways the 8 runners can finish if Jack finishes in a position immediately after Andrea. Okay, so what we have here is we've got 8 possible finishes. First, second, third, fourth, fifth, sixth, seventh, and 8th place. And if Jack is immediately after Andrea, okay, well, so if Andrea is there and Jack is there, and then everyone else are in the last positions. So long as it always finishes with Andrea and Jack, and then we've got all these other runners. Well, that would be the position if they finished all together, or if they finished first and second. I think you can kind of see from this R2. We can have all sorts of positions there, but realistically, these guys are a single unit. They always finish Andrea, then Jack. That's what this says. So what this actually is 7 factorial. Because while there's 8 runners, Jack and Andrea have to finish with Andrea first, then Jack. So we can kind of treat them just as one runner altogether. So it's 7 factorial. And 7 factorial, I don't know off the top of my head. So let's try 7 factorial. And I get 5,040. So there's 5,040 different ways. 5,040 ways. Because again, it doesn't have to be this is always the first, like we could always do. This is one of the 7 ways. We got it. Okay, if Jack finishes in any position after Andrea. Okay. So this is one of the ways that can happen. Another way that could happen is Andrea's first, and then R1 is here, and then Jack, and then R2, R3, R4, R5, and R6, right? So that would be 2 different ways that could happen. There'd be a third different way where Jack is in 4th place, and a 5th different way where Jack is in 3rd place, and a 6th different way where Jack is in 6th, and a 7th and an 8th different way. That is with Andrea coming in first. So Andrea first, there are, what did we say? We said there's 1, 2, 3, 4, 5, 6, is it 7? Sorry. 1, 2, 3, 4, 5, 6, 7. So there's 7 ways that can happen. And then if Andrea's in second, I'll do this in a different color. If Andrea's in second, Jack has to finish after her. So there's 1 way if Jack finishes there. There's 2 ways if Jack finishes there. There's 3 ways, 4 ways, 5 ways, 6 different ways. So we've got 7 plus 6 more ways, and I think we're going to see a pattern here. If Andrea finishes third, Jack has to be here. There's 1 here, there's 2 here, there's 3 here, there's 4 here, there's 5 here. So we have 5. Andrea's there, we've got 4. If Andrea's there, we've got 3 different ways. If Andrea is there, we get 2 different ways, and if Andrea is there, we get 1 different way. So we have 13, 18, 22, 25, 28 different ways that that can happen. And now, so there's 25 combinations there, and Jack and Andrea are still kind of treated as a single unit. So what we can do with them is everyone else can finish in any of the other 6 spots. So it should be 28 times 6 factorial, because we've already located all of the different ways that they can be, and then we just have to randomize all of the others. So it should be 28 times 6 factorial. 28 times 6 factorial is 2,160 different ways. 20,600. So that is what we can do. I hope that's helpful.